and welcome to part 1 of my series Physics for Dummies. Let's get right into it. So first we're going to be talking about forces. So a force is just a push or pull that can make something move, stop, or change direction. Forces can be strong or weak, and they act in all different directions. For example, up, right, left, down, etc. For example, pushing a door. You're applying a force on it to open the door. And gravity is also a force. It pulls things down into the ground. Forces are just what make things happen. Now let's talk about types of forces. So we're going to keep it super basic for now. We have the gravitational force, which is just the force that pulls things down towards the earth. It's always acting downward into the ground. And basically, imagine this, right? You throw a ball up in the air. The reason it comes down is because of gravity. Earth's gravitational force is pulling it down into the ground. But then, that's not the only force we have. The normal force also exists. And this force just pushes back up when something is sitting on a surface. It's the force, it's like the ground fighting gravity to stop things from falling through it. So, if you right now, you're sitting on your chair and you're not falling through your chair, you're not falling through the ground because the normal force is opposing gravity. And those two forces have the same strength, so they cancel each other out. So gravity pulls things down and the normal force pushes them up. But keep in mind, the normal force is always perpendicular to the surface. It's not always going to be perpendicular. It's not always going to be directly opposite gravity. But we're going to talk more about that in later parts. So now we know that. Let's talk about Isaac Newton's first law of motion. Pretty much, if an object's not moving, it won't start moving unless something pushes it or pulls it. And if it is moving, it will keep moving the same way unless something stops it or changes its directions. So things just don't change unless you make them. For example, if you have a car and the car is just sitting there, it's not going to move. And if you have a car and, if you have a car gliding on ice, it's going to keep gliding on ice until something stops it. But let's go here for a more in-depth explanation. So his first law is also known as the law of inertia. And inertia is just an object resisting change to its state of motion. And a measure of inertia is an object's mass, right? So a car has lots of mass. It has high inertia. It's hard to change its state of motion. It's hard to start moving it. And when a car starts moving, it's hard to stop moving it. So, like I said before, if an object is stationary, it will not start moving unless a force acts on it. And if it's already in motion, it's going to keep moving unless something acts on it. All this means is that there's just no net force acting on an object. For example, a book on a table, it'll stay there unless you push it. And a hockey puck glides across ice with nearly a constant speed because there's almost no friction to stop it. Friction is also a force, but we're going to talk about that later. This law explains why seatbelts are essential when a car stops suddenly, because your body, due to your inertia, wants to keep moving forward. The seatbelt applies an external force on you to stop you from, just ejecting out of the seat. So let's talk about free body diagrams now. So free body diagrams are just a picture that show which way things are pushing or pulling on an object. So to make them, you just draw the object, right? A square, circle, or rectangle is completely fine for this. And then you just add arrows for the pushes and pulls, like gravity pulling down or the normal force pushing up. And the bigger the arrow, the stronger the push or pull. Keep in mind, the diagram is freed, quote unquote, freed from its surroundings. So you only draw the object. It's like showing what's happening to an object with all the forces acting on it, right? And to draw them, the forces have to come from the center. So I'll just give you an example, right? So here we have this car, it's not moving, all right? Let's draw a car. Well, let's just draw the free body diagram for the car. So here is the car. We'll draw it as a rectangle, right? And now, obviously, gravity is pulling the car down into the ground, right? It's the gravity of the earth is keeping the car grounded. So we're going to draw gravity starting from the center and going down. All right, and it has to be an arrow. Then we also have to label it. And we're going to label it F for force. And forces are vectors, keep that in mind. And subscript G, because force of gravity. But then, right, there's also the normal force of the ground acting up, opposing gravity. So we also have to draw that. F, force, N, normal, and it's also a vector. And vectors are just, vectors are just quantities that have size and direction, right? Anyway, so you look at this free body diagram, we should also just label this F, B, D, car. Sorry for the bad handwriting. Anyway, yeah. So this is the car, and these are the forces acting on it. The gravity is pulling down, normal force is pushing up. As you can see, the arrows are the same length, meaning they're the same strength, and they cancel each other out. So F net, I'm going to use sigma notation. Yes, I know, very funny. Equals 0. So balanced forces. Again, excuse the very poor handwriting. It's hard to use a mouse. Anyway, yeah. But we're going to go more in depth in part 2 and 3 and so on and so forth, but this was just a very basic introduction to Newton's first law of motion, free body diagrams, and forces. Right? Anyway, that was Physics for Dummies Part 1. Thank you guys for listening, and come back for Part 2.